All right, so negative 1 over pi, I'm just the messenger, all right? Cosine pi x plus 3 over pi. All right, that's where we were, right? And then everything in purple is in brackets. So here we go, I'm going to do a bracket. This could be a parenthesis. I just did brackets to just emphasize that that's over there. So what do we have? 1 over pi x squared sine pi x minus 2 over pi, new integral, right? X sine pi x dx, close the bracket. That's where we are, right? Are you coming? No? Okay. That's where we are? Now you see this? We're going to go do that over there now. We're almost done though, right? This is the last step. Why is this the last one? That x is going to go to a 1 now, right? And we'll be done. Is here okay if I do it here? We're doing the antiderivative of x sine of pi x dx. Oh, it felt good. Just leave it. I'll get it. U dv, u is the x, and the dv here, let's go with the sine pi x dx. Oops. Sorry about that. Yeah? Yes? du is 1 dx. Antiderivative here, we've done this a few times. Negative 1 over pi cosine pi x. Ultraviolet minus voodoo. Ultraviolet, negative 1 over pi x cosine pi x. That's those two multiplied, right? Minus a space, new integral. What constant can I pull out? Negative 1 over pi, right? So when that negative 1 over pi comes out, it hits here, becomes a plus 1 over pi. What's in the integral? Cosine pi x. Finally, something I can find the antiderivative of, right? So I'm just going to go, I'm going to do it right now. I know I'm going to be hard to see here. Negative 1 over pi x cosine pi x plus 1 over pi times the antiderivative of this is 1 over pi sine pi x, right? Plus c. The antiderivative cosine of pi over x, or pi x, is 1 over pi sine of pi x, but we already had a 1 over pi out there.
Do we ever need to distribute this?
We're going to distribute all this out. Yep. All right, so here's where we were, right? Here's where we were. This is negative 1 over pi x cubed cosine pi x plus 3 over pi. Then I had a bracket. Then I had 1 over pi x squared sine. You were wondering when your work was going to finally start looking like you were doing something, right? Insane, yeah, you're there. Okay, this is everything up to here, right? Then I had another bracket, and then I have all of that, right? Negative 1 over pi x cosine pi x plus, it's 1 over pi twice, right? Multiplied? So I'm going to write 1 over pi squared, because that's what that is, right? And then sine pi x. And then plus c, right? I'm going to close this bracket. I'm going to close the other bracket, and I'm just going to put a plus c out here. It doesn't matter where the plus c is. At the end of the day, it's just a constant being added to everything. All right. Almost. We got maybe 2 distributions to do. Negative 1 over pi x cubed cosine pi x plus, all right, I'm not going to do this one yet. I'm going to go 3 over pi bracket 1 over pi x squared sine pi x. I hate grading these. Okay, let's distribute these through, right? Let's distribute that negative 2 over pi through. So positive 2 over pi squared, that's this times this, so 2 over pi squared. And then this times this one. Oh, well, I should write the rest of it, huh? X cosine pi x. And then minus what? 2 over pi cubed sine pi x, close the bracket, plus c. One more distribution, and I think we're there. Y'all okay? I'm hearing a lot of deep breaths and... Yeah, yeah. You need that old Big Chief stuff, right? Wasn't the Big Chief?
My husband has a giant whiteboard.
Yeah.
I didn't get it.
You get it now, huh?
I get it.
This through here, 3 over pi squared, right? X squared sine pi x. And then this distributes to this, so what will that give me? Minus or, we should have plus, right? 6 over pi cubed x cosine pi x. Last one, here to here, minus 6 over pi to the 4th sine pi x plus c. There it is.
So if we left that in the raw form,
What do you mean? We left it in the raw form, like not distributed?
yeah.
Well, I mean, you're just avoiding the inevitable. Like, you're going to need to have to do that. At differential equations classes, you need to be able to simplify these, manipulate that. Let's see what Wolfram does with this. It was x, what was it? It was x cubed, right?
X cubed sine pi x.
Okay, so x cubed sine pi x, right? See what it does. Do 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 do. There it is. See, students will give me answers like that. My internet students will give me answers like that, and I'm just like, yeah, right. Okay, because what is that? I mean, that's, if you distribute, look at this sine pi x. If you distribute it through here, what would you get? If you go here to here, you would get, and then bring the 3 in. So it'd be 3 pi squared x squared sine pi x squared all over pi to the 4th, which is one of these. It's this one. That's this one. That's that term right there. And then if you distribute the sign to the negative 2 with the 6, you get this one right here. Do you all see that that's not a natural answer for a human to do? This is natural for a human to do. That is not. So, all right. Yeah, right? This is a lot. Yes?
On the test, can we do tests? Can we like grab more sheets of paper?
Yeah, but we're going to make sure you have plenty of paper for the exams, right?
I'm gonna have a problem like this on it.
This is, yeah, I mean, if I show you something in class, I mean, that's fair game. This is not by any stretch like, oh, this is like the most difficult problem. It's integration by parts 3 times, right? We had to do integration by parts 3 times to get this problem to work out. I wouldn't anticipate it going more than 3 though. 3 is probably about as far as I'd ever go.
How do we know?
How do you know what?
How do we know how many times we need to do integration by parts?
Well, that's a great question. Let's just take a step back and think about it again. This was the original problem, right? Oh, no, it wasn't. Cube, dx, right? So think about this. If I let this be the u, the first time I do integration by parts, it can become an x squared, and this one's going to go to a cosine. So now I've got a cosine and x squared. So if I do integration by parts on that again, the x squared goes down to x. And then the cosine becomes a sine. So now I've done it twice, and I've got this thing turned into an x. And I do it a third time, and the x becomes a 1. Right? So it's almost like that power was dictating how many times we had to do it. Yes?
Question, can we do it like this, and then to check if it's right, can we do tabular?
To check if it's right, do tabular. So the tabular way is just an easy way to, well, it's a fast way to do to do all the pieces. You still have to put them all together, right? Yeah. Yes.
So will there ever be like a problem where like, do we ever combine either method? Like say we do integration and then we can use substitution for that?
Yes. Yes. So moving ahead, right? Maybe we're going to get a problem down the road where first you need to do a u substitution. And then you do an integration by parts. I'll give you a good example. This will be our last one. I guess we're not talking much about the test. I mean, I wasn't going to hand out a review to you right now or anything like that either. I will send you an email after class later on today. I will send you an email that'll give you some sort of guidance as to the exam. It's our first exam, right? It's going to cover everything we've done up until today. This, though, basic problem. Like one integration by parts, not 3 of them in one problem. Just a basic one. Yes?
So the homework says 5.5 and 6.1. Is that just kind of like what we're covering, or does that mean we have to do use of and integration by parts?
On the homework, when I send you the email, I'll tell you what problem to go up to on the homework, and that'll be all you need to do to be prepared for the test. Is that what you're asking?
Well, just if it was just integration by parts, or we needed to do like the example that we're about to do right now. Like
The
it's
homework
total
listed is like
combined.
5.5, 6.1, 1 page, 1 through 7.
One page, 1 through, it only says 1 through 7. Okay, so that's all you have to worry about.
Okay.
So what I'm doing right now, this is in this section, but it wouldn't be on the test. Is that all right?
When
Sure.
When
What?
will we be receiving the email?
Later today. So look at this one. Basic U sub is not going to work. Basic U sub doesn't work. Right? It doesn't look like it works. But what else do you do, right? If you do integration by parts, what are you going to have for your integration by parts? You only have one choice, right? What's your only choice for integration by parts? E to the square root of x. Okay, and then over here, dv would have to be what? 1 dx, right? That's your only choice. That's it. That's the only thing you can do. All right, let's pause. Let's make a substitution. Wait a minute, I thought we just said substitution's not going to work. Let's make this substitution. What's the derivative of this? So I'm not doing this, right? 1 over 2 root x, right? dx, sorry, dx. Yes? But see, we don't see this anywhere, do we? Right, that's our u, right? We don't see its derivative anywhere, do we? So it looks like this isn't going to work. But watch. If I multiply both sides by 2 root x, do you believe this? That this becomes this, right? Yeah. But what's the square root of x? It's u, isn't it? So this line can be rewritten how? 2u du equals dx. And now rewrite this problem. E to the x becomes e to the what? U, right? E to the u. And what does dx become? 2u du. Looks like I've lost everybody here. This is 2 integral u e to the u du. And this integral right here, we did earlier. Didn't we do x e to the x? We did that earlier with integration by parts. We would have to do that. I'm not going to do that. I'm not going to finish the problem. We'll come back and we'll do this. Like someone asked, is there ever going to be a combination? There's a perfect example of a substitution that was required before, and once we did the substitution, which was not a natural substitution. How did I know to do this? Well, because I know the problem, like I've done it. But this substitution would come after you're like, shit, I don't know what to do. Like, I need to try something, right? So you try it and you go, oh, wait a minute, hold on. This is what u is, right? And then you get this new thing. All right, so yeah, we've got 5 minutes. Let's just talk a little bit about the exam, all right, because I don't want to just say nothing about it. How much is this exam worth? I don't remember. Let me see if I can get to this. It's 15%?
Yes.
And the ones later on are worth?
20, 20, and 25 for the final.
Yeah, so if we look at our syllabus, there it is. Our syllabus says that exam 1 is 15% of your grade. And then the next 2 are 20 and the last one's 25. So the reason it's worth 15% is a couple of things. There's not a ton of material on this test in terms of like both difficulty and scope. And the first part of this is derivatives, right? Inverse trig stuff, hyperbolic stuff, a lot of derivatives in the beginning. And then we went to antiderivatives, just like what do we know from Cal 1? And then we did basic U substitution, and then now a little bit of integration by parts, right? So that's why that test isn't weighted as much. So that's good and bad. Good, I guess, that you can't completely like destroy your grade on this test because it's only 15%. But at the same time, if you do well, it's only 15% of your grade. You still have to prove yourself on exams 2, 3, and 4. So material-wise, like I said, it's going to go up through. So we've done everything here, right? We didn't miss anything. Inverse trig, hyperbolic, antiderivative, substitution rule, integration by parts. That's it. So how do you study for this? You probably get together with somebody or not, however you want to do it, but take out all your homework, right? Lay it out section by section. You lay out your notes. You go through problems. You go through the problems we did in class, right? Practice the testing environment. Give yourself some problems on a piece of paper. Put everything away. Turn off the TV. Put your phone aside. Time yourself, right? Practice that environment. You're allowed to have your formula sheets, and that's it. Only your formula sheets. The integration by parts formula is on your formula sheets. Okay, it's there. Reference page, I'm not sure which one.
6.
Reference page 6. It's the first formula. It's the very first formula, top left. That's it. You have to print the formula sheets. I will not provide them for you. So bring them in. We'll come in, we'll sit down, I'll hand you the test, you'll have the whole class, and then when the time's up, test is over, you leave. If you finish early, you can leave, yes.
Do you know about how many questions there will be?
I don't. I haven't made the test yet. We can look at an old one. You want to look at an old one?
Can you send that to?
I'm not going to send you any old test.
Do you offer any bonus questions on the test?
There may be a bonus, yes. There could be. Let's see what I can find here.
And I would always forget. Bro, that one question that you'll say, you know, put it on like, then you put on the final edit. I still got it wrong both times.
So to give you some idea, this is just to give you an idea, all right? Some things I've asked in the past. I gave some equations and asked for derivatives. This one right here requires an implicit differentiation. So again, these first ones were all with the inverse trig functions. Then I asked for them to show this identity is true, show that cosine hyperbolic x minus sine hyperbolic x equals e to the x. And then the rest of it is, antiderivatives. So this one, how would you do that?
You gotta break them up and then X.
Split it up into individual pieces and then use your power rule. This is one of the ones where I give it the second derivative. I want you to go back to the original function. I give you some initial conditions. This one, u sub, u sub, u sub, u sub, u sub. No, sorry, integration by parts, integration by parts, integration by parts.
What were those questions on the quiz today?
Maybe. Which one?
E to the tangent?
E to the tangent. Yeah, that was on the quiz today, wasn't it? What is the u sub here?
Because it's the same thing as,
Yeah, tangent x, the derivative of that is secant squared. And isn't that what 1 over cosine squared is? Okay. So does that give you some indication of what I've asked in the past? I mean, that in no way is that like, oh, that's what we're going to see. He's going to give us, number 1 is going to be inverse trig derivatives, but that just gives you a flavor of what I've done in the past. 12 questions here. So I always try and do it where I feel like you have enough time to take the test. That's always different for every student, right? Like some students take a long time. But, I mean, this part of this class is not just can you do it, but can you do it efficiently in a timely manner, right? So I've been doing this for 20 years. I've been teaching Cal 2 for 20 years. So I know what a Cal 2 student how much time it should take to finish a test. So unless you have some sort of letter from the access office that allows you extra test time, then everyone gets the same amount of time. So you get the full class period. Anything else? This is the easiest test of the semester. So it's a good chance for you to get your footing solid in this class. So make sure that you prepare for it, all right? Yes?
should it be the entire class period?
The whole class period, 100 minutes. So be on time, be rested, be fed, be ready to go. Yeah? No pizza though, no coffee. Not bringing pizza or donuts. All right, good luck everyone. And then make sure you bring that problem, the quiz from today, bring that next class on Tuesday. No Costco pizza. Too early for pizza. I don't think they're not open that early.